Problem 13.15. Show that the rule in section 7 for calculating the expected step frequencies applies also when we test the null hypothesis that we are sampling our populations with identical multinomial distributions. Okay, so what that means is, suppose we have x1s or xr, they are vectors, there are all n-dimensional vectors, sorry, k-dimensional vectors. So each of them is following this distribution and they're independent. So the multinomial distribution is a distribution. Remember that it's a distribution. It's a discrete random variable. If x is following this, that means x is a discrete random variable that has k components. We basically have if x is following the multinomial, and P1 through Pk. So this x is actually, we'll say, it has just have k components. I would say x1 through xk. Okay, and so each of this is a number, it's an integer between 0 and n. The sum of them should be equal to n. So what that means is you have n things, n objects, you distribute into k drawers, and the probability of getting the first drawer will have a probability P1 of getting each of these objects. Okay, so you have n objects distributed into k drawers, and each drawer has this property. So remember that this P1 so Pk, they are values between 0 and 1, and they sum to 1. Okay, so this is a straightforward extension of the binomial, where you only have the P1 and P2, and P2 is automatically P1, 1 minus P1. Okay, so this is the extension for that. But anyway, so when we have observations, we have R observations. R is just to be aligned with the R by C table. So there are R rows. Okay, so now for each of these, we'll have so x1. We know that we have x1. Maybe I should use this as so. We have x1 1 through x1 k, right? So this should be that. And then we have the xr, and it should be x r1 through xrk. Remember that the sum of these k things should be equal to n. Every one, so every row, this should be summed to n, and the probability of, the x, this one, for example, this one over the n should be approximately equal to P1, right? And similarly, this one over the over n should be approximately the Pk, okay? Because there's a number of say balls falling into each of those drawers, k drawers. Okay, so that's why we can actually, if we really have observation, then we can actually form this R by K table, right? R by K table. So this will give us a R by K table. We will have this many R rows, and then we have those many columns. So it's R rows by K columns. And then if they are following the same multinomial distribution, then they should have the same proportion in each column, right? That's what actually the purpose of doing the R by C table is, to test if each column has the same proportion in their own population. And that means the null hypothesis this, and that essentially just means that if they all have the same P1 through Pk, or some of them has a different P1 through Pk than others. So that's why the same method of R by C table can be used to test the if these random samples following the multinomial distribution have the same parameters here.